Good afternoon, everyone. I would like to speak about markets and services which are technically suitable and applicable to nuclear plants. And these results are generic results, and they are based mostly on the results we have seen with nuclear plants in Germany. And why we did like that, I would be explaining the next slide, please. So as you have heard from several already, the situation is that 4 regions which the GINO group decided to be most interesting for Nordic because of similarity. We found out that in these 4 regions, the nuclear is existing only in UK and in Texas, and in both of them, the flexibility of the nuclear is not so strong. So as we know that in US, they're mostly working in base load and only looking for an opportunity of flexibility. And in UK, of course, the new builds would be flexible, but from an existing point of view, only the COVID period gave us an example of Sizewell B NPP performing in 50% due to the low demand in the grid. There are 2 countries which have the strongest flexible operation experience in the world, and it's France and Germany. And why we decided to look at Germany, because first of all, it has very strong penetration of relative renewable energy. So today we have really 40% from renewables, and 2/3 of that is coming from wind and solar. We have hours in our grid when we have 100% from renewables, and we have hours when we have 2% from renewables with biomass. So this difference has to be somehow regulated by conventional NPPs, and the nuclear is participating very strongly on this regulation. Also compared, for example, to EDF, which has on one hand 58 plants, and the flexibility can be decided to be performed with some plants, the new plants, more flexibility together, and the others can be in baseload. This is not the situation for the nuclear in Germany. The utilities don't have so much plants. So the result is that each particular plant, both P and D BWRs in Germany, has to be much more flexible, each of them. And that's why we think it's probably one of the best examples and references to look for the Nordic system. The next slide, please. So what was going on in Germany? So we had 1991, the feed-in tariff coming for renewables, which were non-dispatchable energy. And 2008 became the market liberalization, which allowed negative prices. So there were really moments of such numbers of minus 500 megawatt hour per euro per megawatt hour. And even today we have so-called 6-hour rule. So after 5 hours, if there's still a negative price on the market, the renewables will not get subsidized anymore. Everybody expected that there will be not so many negative hours anymore, but it was not the case. So to give a feeling of negative hours in Germany, we have 2018 with about 211, and only March 2020, because of COVID topic and the pandemic impact, we had alone 130 negative hours. So overall, the negative prices are coming when we have too much renewables and not enough for demand. So the best case was in the COVID time. And as what we told before, it was totally big surprise for people all over the world. And after the COVID, it's not anymore such a big surprise. So as I've heard, the Nordic got also some negative numbers this year. And in this moment, when it started, the nuclear power plants in Germany tried to analyze very fast the possibility or capabilities of the plant and start pilot projects, different types of, to increase the flexibility. And first of all, to give much more opportunity on the energy market, not to provide for negative, but to buy for negative. And also today we have a participation on intraday market, which also additional revenue for the plants or for the utilities. On the other hand side, please the next slide. We have also the second possibility, and it is providing our ancillary services in new markets, in reserve and balancing markets. And the German plants started participation and increased stepwise the level of participation for their NPPs. The pricing and the revenues are very volunteer, similar as the energy market. So sometimes the primary was very interesting, then the tertiary minus or minute reserve. But anyway, what are the services which are provided by NPPs is the FCR. So we'll try to use the European wording for it, or in Germany we call it primary control. The activation of time in 30 seconds, duration less than 15 minutes. In secondary balancing, 5 minutes response, and the MFFR, the 15 minutes response. The procurement of these services changed over the years. So it was weekly, and now all of them are daily. And we have capacity, so we are paid just for being ready for providing for all of them, and additionally have an energy price for RFFR and MFFR. Typical difference between these are that RFFR has to be remote controlled and MFFR can be both, so it can be manually activated or automatically. So these markets gave additional opportunities for the German NPPs, which they used to a strong level in last 15 years. Thank you. The next slide, please. Hello, Monica? Okay. Just I would like to stress this topic also because I think it's also important for the Nordic. So we have additional service which the nuclear plants is giving to the society and to the grid, and it is participation on redispatch measures. And on the left-hand side, we have the development of the grid, and on the other hand side, two other pictures are showing the redispatch measures downwards and upwards. And it's typically like that the electricity will be needed in the south, but produced by wind parks in the north, so it cannot go through. So some plants have to go down, and it's very typical for the Brokdorf, our nuclear plant of ProSienelectra in the north, that they have to go down. And it's quite often that such kind of service is carried out by NPPs. The next one. So the voltage control, it was for me the new topic. So we have heard already nice presentation in the beginning. So I would give an illustration from the German life. And it is, of course, a local service, and the prices are approved by regulator. And it was previously, or for example, we at Framatom, we always thought, till I started this interviews, we thought that the plants are working in overexcited mode, but it is not the case anymore. So this is the example of 1,500 megawatt electric plant, which shows us 1 year curve where they are mostly all the time in underexcited mode. So, and with the typical activation of 200 megavar minus until the maximum value of 350. And it's not very favorable mode for the NPPs. And what is making it especially nice that this kind of service is not rewarded at all. So the NPPs, and they are really fighting for kind of adequate payment, and they say they would like to have our own market, but there are also different workings group, but still, till now, it's not the case. Okay, next one. So these kind of services are provided to the grid, and on the other hand side, the plant has to perform them. And in the plant life, we call this kind of providing of the services with special plant mode, and the one is called load following. It's typically what we use for energy market, for economic dispatch, redispatch services. We know the ramp, we know the level where we have to go, we know the duration, and typically there's a load schedule for it. It's adaptation to the daily demand variation. Then we have the frequency control, FCR, RFFR, MFFR. And then we have some emergency measures typically know also how long we should stay on such level and try to come fast there, and then we know already when we have to come back. And there are special type extended low power operation is when you have to reduce the power for a longer level, and typically you also know how long you have to stay, and it's defined differently, typically more than 24 hours. And depends on the mode, there are also different impacts on different things that has to be optimized and looked at when the plant is going on this kind of operation. For example, for frequency control, surely it is in the ANC which will be improved. And for example, for extended low power operation, it is the maintenance issues, this optimization of the lifetime issues, vibration, corrosion, whatever, fatigue on the secondary side of the plant. The next one, please. So now we go through the typical ancillary services and to look for the real plant operational curves. And on these, we start with the primary frequency control, our 30-second response. And on the right-hand side, you have our world record with the so-called advanced load following control system, where the turbine and reactor control are working perfectly together. And it was possible to do 200 megawatt electric downward step. It was not afterwards performed often. I would say the plant have done primary control increase the range over the years from 30 megawatt to 150 megawatt electric. And the on the left-hand side, we have another plant where we see the pre-qualification symmetric test for 100 megawatt electric plus minus. And typically, what the grid really needs, what the grid is typically asking for in a normal life, it's about plus minus 50 megawatt electric. But what the plants are qualified for, P and BWRs, it's very different, depends on the plant and also on the time, if they are already, these plants are not operating anymore. But to give an overall overview, the values are between 2% plus minus to 10% of the rated electrical output. And these service will be performed from 100% or a bit lower, depends on if you do plus minus or only minus, till about 50 or 60% of the plant output. So the next one, please. This is the secondary frequency control, or called RFR. This is also one pre-qualification test of also symmetric plus minus 150 megawatt electric. For the secondary and tertiary, how we call it, we are defining the ramp rate and the level, the lowest level you're performing your service. And these ramp rates are from 10 to 30 megawatt per minute, depends on the plant. There are also examples of 40 megawatt per minute existing. And the level from 100 to 50 or 60 level, 60% level. So it's typically that BWRs are trying to perform services in the level where they are having recirculation control mostly, not using too much control rods. And the PWRs are trying not to have big differences in the primary temperature, average temperature. So these services, as I already said, primary, second, tertiary, all of them can be performed asymmetric. So it means that it is possible to do only downwards, and the upwards can be done by others participants, by other plants. So it makes it more easier, the decision for the plant to participate on ancillary services, because such possibility is existing. The next one, please. So this is the tertiary or minute reserve. It's this 15-minute response. It's I would say that it's provided in 15 minutes, and it's again one example of two different plants which are doing only minus, only downwards. I think we have here something about 200 megawatt changers. And it's what could be said the same. It's from 10 to 30 megawatt electric per minute is the ramp range, and it can be performed within a range from 100 to 50 or 60 percent of the electrical output. This service could be, as I said, or done manually requested, or also could be fully automatically, like one plant has shown us. The next one. So this is this example which I wanted to show. It's showing us one plant which optimized and automated everything. So all requests which are coming in are going some kind of computer which analyzed what is the best for the grid, how primary, secondary, tertiary, load following, request, redispatch, how it all should work together, and then provide the right request for the plant. The operator is putting the set point itself, and saying which gradient he allows and which level is allowed. This level is typically proposed for the whole year, but all the time if something change, you have some numbers here provided day ahead, so you can change whatever you need. And there are of course limitations in the year, so we have some time in the plant year where you're not providing the flexibility, like for example in the start of the startup phase, because of conditioning time, and also where you need the experiments to be carried out, calibration. So it would about 4 till 6 weeks in the year when the plant is not performing flexibility. But it's known, but it's by the load dispatcher, and the load dispatcher is providing the best economically and safety, the best solution for the utility. And in this case, we have 560 megawatt fully automatic remote controlled, which are given to grid as a support for various types of flexibility, which flexible services, which we don't see here what is exactly provided in this moment. And it is 1 month what we see now. And it's a PWR, so in this case, the big issue is xenon, and the xenon is compensated by boron demineralized water in an automatic way, and also the oscillations are not there due to very good reactor control with advanced load following control. The next one. And this is my favorite slide, because I always ask myself, so what was the difference over the years? Can we really see on one example, one plant, what's changed? So it's changing extremely. So from 2002 to 19, so in 17 years, we have increased of the gradient from 10 to 30 megawatt per minute. But it's not only the gradient, it's also the number of requests which the plant is getting over the year. And of course, this kind of increase was possible due to some improvements, which Framatom carried out for this NPP. For example, we have on the right-hand side also interesting feature of the reactivity management, that the plant knows where it is, that it doesn't have a red black box, and so on. But what is also very important is, of course, to provide these services always in reliable and safe manner. And when I had an interview with the plant, they all said that it's very important to look at the maintenance concept and preventive maintenance. For an example of this plant, really there were no increase in events number over these years. So much more flexibility provided, but no big problems, because you know where to look at and where to look at and how to do it in the best way. The next one. So just to conclude, so after we looked all together with the team, so we see that of course, the new nuclear power plants which will be built will be flexible strongly in the Nordic grid. And to some extent, the existing plants are also technically able to provide various services, frequency and voltage control, to be also used for the dispatch, redispatch during the day, but they need, of course, an adequate market design. If we go through the services which were found to be important for the Nordic for the next time, the fast frequency reserve product, we don't think that it's really good for NPP. The FCRN, the result was that it should be partly replaced by RFFR, and in the end, RFFR could be provided by NPPs. And if FCRN still existing, I think the boundary conditions are like that, the NPP can also participate. FCRD, we see that there's a new project which is working on these on this service, on the design of this service, and this one should be looked in detail because there are some difficulties due to big activation already in 5 seconds. But still, I discussed this with some professions in this field. They said it should be looked at plant by plant, and using, for example, closed loop simulators in the outage time to look what could be increased, what could be changed. If there is a business case for the plant, it makes sense to look for it. So in general, the air frequency restoration reserve, automatic and manual, both could be the best candidates for ancillary services products for NPPs. And each plant has to be looked in particular with whole history. So what is designed for, what was provided, which kind of transients has been done already, if we have a power up rate, what is the lifetime expectation, and all these things, power history, all this has to be analyzed to give the real answer for one plant, where it stays now and what can be done to improve the flexibility. And on the other hand side, the business has business cases needed for the plant to take all these measures. Each flexibility has its own cost, so it cannot be free of pay. So it should be carried out in detail to give a decision, to make a decision to participate or not. So thank you very much. This is all from my side, and we're open for your question. And thank you for the group for a very interesting project.
Thank you very much, Tatjana. And I would also like to take the opportunity to thank Seppo Henninen. Seppo, you have been engaged in so many different projects, and now you've started a new journey with a new life as retired. And I just want to thank you and wish you best of luck with your new life. And then I open up the floor for questions. So either raise your hand or write in the chat. I think it's a really interesting area that we have studied, and I think that it will be increasingly important also in the future. Are there no questions for? Yes, one Thomas Smed, please.
Yes, Tatjana, you talked about business case and things like that, and I'm curious, your price level have you seen on, for instance, FCRN?
Sorry, I didn't analyze price level at all. So it's not. It was not the
it's
part.
More for the utilities, not for you as a vendor. I understand.
Yeah. So I think it's the next step. It's most important. So we have to do the business case from both sides. We have to say, okay, this is the plant. This is what we have to improve here on the plant. This is what the flexibility will cost because we need more and whatever, more steps. But on the other hand side, this is what we can particularly perhaps win. And I think there are some models. So I spoke with utilities, how they do it, how evaluate, they look backwards 3 years, whatever, what they would win if they will be flexible and to which level. But so this is how it's carried out. But on our technical level, we don't know what they do there.
Okay, thank you. Matthias has a question.
Please, Matthias.
Unmute as well. There we go. No obvious question, to be honest, but thank you for an excellent presentation. It's a lot of information. It takes some time to digest all of it. I think it has been very interesting. But anyhow, regarding questions, I did find one because I found that Tatjana had one slide, which I found very informative regarding the evolution of the need of the services from 2002 and 2012, I think it was. So my question is to Seppo, actually. Did you see something similar in the other markets that you studied? Did you have access to that information? What was the evolution of the services being offered on the market in, for example, UK, Texas, Australia? Did they increase over the year, and what was the drivers of that change? Or maybe you didn't have time to look into that?
No, if I try to answer this question, I understand your question in general level of the development of the ancillary services market, that of the main driver is that in these countries that the wind energy or got the flexibility in the grid, but the problem in the Nordic grid is that, and also the other, that the grids are different, and the size of the grids are different, and also the ancillary services that are needed to balance the grid, that they are somehow different in each of these countries, in spite of the fact that they have somehow similarities. But of course, the one driver is in the Nordic system is probably the lack of inertia in the future, and therefore we need somehow faster ancillary services for that purpose. But and also that the one thing that we concluded is also that the grid, the size and the power sources that are applied in these other markets and areas, that they have that, for example, the Australia and UK, in the West Texas, that there somehow sensibility to grids that they need very fast, because they are longer distances and these kind of things in these areas. But probably the main driver for developing the market, that the flexibility, what is the reality that the flexibility is increasing due to that the intermittent wind and solar generation that are increased in all of these areas.
Yes, and here is Corentin from VTT as well, and I'd like to add to this that we haven't gotten to the same kind of curves as what Tatiana has showed, but we can see the same trend in the form that the price of flexibility services is going up in all of the regions.